All right, guys, so we are going to talk about 7.1, which is our introduction to air pollution or pollutants. And so the objective is that you will be able to identify the sources and the effects of air pollution, or sorry, air pollutants. So, just a few brief air pollution basics that you need to know and understand is that in terms of the AP exam, especially in FRQs, you need to write about air pollutants. You need to write about specific molecules and particles, and you can't just use the term air pollution as an idea. It needs to be specific. Um, the other piece that you need to know is that much of what we do surrounding air pollution has its roots in the Clean Air Act, which was passed in 1970, and it identified 6 criteria air pollutants. And those air pollutants are the ones that the EPA is required to regulate, and they set acceptable limits for these air pollutants. They monitor and enforce those limits in industry. Um, so the 6 pollutants are sulfur dioxide, which is SO2, and that's going to come primarily from coal combustion for the purposes of generating electricity. When SO2 is in the atmosphere, it's considered a respiratory irritant, especially problematic to those that may have asthma or other lung related illnesses. It is also a precursor to smog formation. And when it combines with water in the atmosphere, it's going to cause acid rain or acid precipitation. Nitrogen oxides, we refer to these as NOx because we're talking about both uh, NO and NO2. And this is coming primarily from the combustion of fossil fuels, primarily gasoline, or especially gasoline, and coming from the use of cars and other forms of transportation. It is an ingredient in tropospheric ozone formation. It is also an important ingredient in photochemical smog formation and also acid precipitation. So you should note that SO2 is going to be a part of smog formation, but that is industrial smog formation, whereas NOx is looking at photochemical smog formation. And we'll talk more about that in 7.2. The third criteria air pollutant regulated by the EPA is carbon monoxide. So carbon monoxide is going to come from the incomplete combustion of fossil fuels, biomass, really any combustion reaction that is lacking oxygen will produce carbon monoxide. It can also lead to the formation of tropospheric ozone. And the biggest thing to note, and we'll talk more about this when we talk about indoor air pollutants, is that carbon monoxide is lethal to humans. It will bind to the hemoglobin in your blood, and so it will reduce your blood's ability to transport oxygen throughout your body. Lead is another criteria air pollutant, primarily coming from the smelting of metal, but also coming from waste incineration, especially from medical waste incineration. And it's extremely problematic because lead is a known neurotoxicant, so it can cause neurological issues. Especially in young children when the amount of lead can be seemingly greater in terms of the ratio between the amount of lead and body mass and things like that. Ozone at the tropospheric level is also a criteria air pollutant, and it's coming from essentially the photochemical oxidation of nitrogen dioxide. So that nitrogen dioxide, when it gets into the air, it reacts with sunlight and it's going to form um, ozone. Ozone is a respiratory irritant. It's also an ingredient in photochemical smog formation, and high levels of tropospheric ozone can impede plants' ability to photosynthesize, so it can cause damage to plant life. And the last and final criteria air pollutant is particulate matter. Particulate matter is coming from the combustion of fossil fuels and also the combustion of biomass. It is a respiratory irritant. It can also be an ingredient in industrial smog formation. So now we need to take a look at air pollutants versus greenhouse gases. So maybe you noticed that carbon dioxide was not listed as one of the 6 criteria air pollutants. It wasn't part of the original 6 from the Clean Air Act, although in 2007, the Supreme Court did rule that the EPA could regulate greenhouse gases. And so it began regulating greenhouse gases in 2009. However, it's not considered a criteria air pollutant because it does not directly lower air quality from a human health standpoint. So while it is a greenhouse gas, it is not toxic to organisms to breathe it in at normal levels. It is not damaging to the eyes and the lungs. It is not going to lead to smog formation or decreased visibility. So it doesn't get that same designation as a criteria air pollutant as those other ones that we just mentioned. It is, in fact, a greenhouse gas, and it does lead to warming of the Earth's atmosphere and therefore indirect environmental and human health consequences, which is why the Supreme Court did rule in 2007 that the EPA could begin regulating carbon dioxide emissions. But bottom line, for the purposes of APES, FRQs, do not use carbon dioxide as an air pollutant. Stick to the surefire air pollutants, the SO2, the NO2, the ozone, the particulate matter, when you're when you're being asked to identify air pollutants in FRQs. All right, so we need to talk a little bit about coal combustion. So coal combustion releases more air pollutants than any of the other fossil fuels. We consider it the dirtiest form of energy, like we talked about in the last unit, but it does create approximately 35%, so more than a third of all global electricity is coming from the burning of coal. So there's a whole laundry list of things that are going to be released as a result of coal combustion. So it's going to release carbon monoxide, carbon dioxide, sulfur dioxide, NOx, toxic metals like mercury, arsenic, and lead, and then, of course, particulate matter, and that particulate matter can have toxic metals in it. The biggest one, though, or the one that I want you to focus on when you think about coal, is that it releases a great deal of sulfur dioxide. And so the things that you need to think about in terms of coal combustion and sulfur dioxide are that it's a respiratory irritant. So it's going to cause, when you breathe it in, it's going to cause inflammation of your bronchioles. It's going to exacerbate things like asthma and bronchitis. When you have sulfur dioxide as aerosols, so they're kind of suspended sulfate particles in the atmosphere, that's actually going to block sunlight. It's going to reduce visibility. It can decrease photosynthetic activity. Coal combustion and sulfur dioxide were linked very strongly to the formation of sulfurous, or what they call industrial smog. This was the London smog, was this type of smog, and the ones that really precipitated kind of a look at air pollution in general. And then finally, when it combines with water and oxygen in the atmosphere, it's going to form sulfuric acid. And then that's going to lead to acid precipitation. So acid rain or acid snow, acid deposition in general. Nitrogen oxides, and we refer to them as NOx, this is going to come from the combustion really of anything, but specifically fossil fuels and biomass. So when we combust those, we're going to release NOx. And so NOx refers to both nitrogen dioxide and then nitrogen monoxide. So NO is going to form when the nitrogen in the air, remember that the atmosphere is 78% nitrogen, and when it's going to combine with oxygen during combustion. And so we'll have a nitrogen molecule and an oxygen molecule, and we'll end up with two nitric oxide molecules. So NO in the atmosphere can then become NO2 if it reacts with ozone or oxygen. And then sunlight can convert that NO2 back into NO. So we have kind of a very quick turnaround between those two things. So environmental and human health impacts of nitrogen oxides. To be honest, you're going to see respiratory irritant almost in every one of these. So if you get stuck on an FRQ and you're running out of time, you really just need to say you're looking for a human health implication of air pollutants. 9 times out of 10, you'll be good with calling it a respiratory irritant. It also leads to the formation of tropospheric ozone, which is then an ingredient in photochemical smog. And then similarly to SO2, NO2 is going to lead to the formation of nitric acid, which is then becomes acid deposition or acid precipitation. So the EPA and lead. So prior to the Clean Air Act, lead was a really common ingredient in gasoline. Engines at the time really rattled, and when you, as they combusted gasoline, and so when there was lead in the gasoline, it helped to reduce that knocking of the engine. But the EPA began to phase out lead from gasoline starting in 1974 because they came up with the idea of putting catalytic converters on cars to reduce NOx emissions and carbon monoxide. And those catalytic converters were damaged by lead. So we started to phase out the use of lead in gasoline. In addition, studies were showing that lead was a neurotoxicant and really damaging to the nervous systems of humans. And so another reason to phase out the use of lead in gasoline. So if we kind of look at the trend over time, the phasing out of lead in gasoline and eventually in paints has really, really dramatically decreased the concentration of lead in our atmosphere. And so finally, we need to kind of know the difference between primary and secondary air pollutants. So our primary air pollutants are things that are going to be emitted directly from the source into the atmosphere. So directly from vehicles or from a factory, or could be even a natural source like a volcano or a forest fire. And so these are most of the criteria air pollutants. So these are NOx, these are carbon monoxide, VOCs, sulfur dioxide, particulate matter. These are all considered primary air pollutants. Secondary air pollutants, you take a primary air pollutant and when in the presence of sunlight and water and or oxygen, it's going to transform into something else. So most often these secondary air pollutants are going to form during the day because the sun is helping to catalyze that reaction. And so some examples of secondary air pollutants are tropospheric ozone, which is a criteria air pollutant, and then our sulfuric acid and our nitric acid, sulfates, and nitrates, which are part of acid precipitation. So your practice FRQ for 7.1 is that EPA scientists performed an experiment where coal was burned in different chambers at varying temperatures to see how temperature impacts the amount of NOx produced by coal combustion. So I want you to think about how the results of that study might be expected to change if the same experiment were repeated with natural gas. All right, that's it.